All right, y'all. Let's go going with what we need to get through. So, on things like this, we need to make sure we change the base. So this is what we did yesterday. 100%, there should not be rustling to dig out stuff. So if I know that this one has a base of 3, how can I rewrite 9 so it has the same base? 3 squared. So this is the same thing as 3 squared. And it gets to keep its old exponent. So it's going to keep its x plus 1 over here. We're going to just bring down our 3 to the x plus 6. When we have a power raised to a power, we need to do what? Multiply. So I'm going to write it still as an exponent here. We're going to have our 3x plus 6 and 3 to the 2 times x plus 1. Ooh, I'm going to change this view because I feel like I'm writing really small. There we go. Now that those bases match, it doesn't really matter anymore. Once the bases match, all we care about is when do the exponents match. So when does x plus 6 equal 2 times x plus 1? Yeah, we got to multiply it out to get there, but I'm pretty sure, yeah, that's right. Because we're going to have our x plus 6, and we need to multiply out the right-hand side to x plus 2. Bless you. And yeah, you guys can finish solving it. Like, that's a skill you guys have. You should have ended up with x equals 4. Sorry. Finish solving. On the right-hand one, it's very, very similar. But how can I rewrite 8? 2 to the 3rd. That's the big piece on these, is figuring out how to rewrite the base in a way that makes sense. So if 2 to the 3rd is the same thing as 2 to the 3x, what does x equal? 1. This one we might not even need to separate pieces out here. We can kind of spot it a little bit early. This piece has to equal 1 in order for this piece to match. So as we get the hang of these, we're going to get better and better and faster at finding those pieces that need to go together. Finishing it out and solving them. Okay? So we are going to be in our notebooks today. We are going to head back into the bank and story type problems, financials. We're going to take our formula that we were working with, not yesterday, but the day before. I'm just going to write it up here just for visuals. So our A, 1 plus or minus R to the X. We're going to take this and we're going to add one more piece to it. It goes in a couple of places, but we're going to add one more piece to it. And that's changes when we compound interest. So what we're going to be doing today is called compound interest. This equation just deals with calculating the interest once per year. Like, it just does it for the 1 year. Most banks give you interest every month. Like, every month you'll get your interest into your bank account. Things like credit cards tend to charge you interest a little bit more frequently, and things get a little cray. So we're going to have a new formula. I've got it right up here on the edge, and I don't like that. Sorry, it is right behind that. I'm going to rewrite that down below it just because it's right underneath that closing symbol over there. So we've got our A, P, 1 plus or minus, that's what I'm rewriting, R over N to the NT. Yeah, it's right under the close and minimize of the program. I don't like it. all of the pieces are the same. So we had been working with little a 1 plus or minus r to the x, where a was our starting amount. Notice that we've got starting amount in the same place. R is still our rate. What we put as our time, or how many times we did it, or what our exponent was, still the same over here. We just are using a t. So this is more of a financial equation, whereas this was useful in lots of different kinds. This one is almost exclusively used in banking. So we still have our starting amount. We still have our rate as a decimal. We're still using time as an exponent. And our last piece here we have is n. It's called the compounding factor. And we use it in two places. We have it in here dividing the rate, and we have it up here multiplying our exponent. And this is a value that we will tell you. Like, we will tell you it is compounding monthly, or we will compound it daily, or we can do semi-annually or quarterly or something. We will tell you what that is. And what it's asking is how many months per whatever our unit of time is, usually years. So it would be 12 months in a year, or 365 days in a year. So we don't have to do any like crazy calculations to get our compounding factor. It's just substituting in another piece. So this P is our starting amount. It's called the principal. And it's the exact same thing as our starting amount before. The rate is still our rate as a decimal. And our exponent is still going to be based on our time. We just have to put in this compounding factor piece. Okay? So let's go try it. I'm going to write our equation over here. So here's our A equals P. 1 plus or minus R over N to the NT. So that's that formula. And what we're going to do is we're going to look at this story about Celeste here. Celeste deposits $1,000 into a savings account that earns 4% interest. We're calculating her balance after 18 years if it is compounded in these two different ways. So we're going to write two equations, and we're going to type it in the calculator twice. So I'm going to start with the annually. Most of the pieces are coming from elsewhere. So what is her starting amount? What is her principal? $1,000. She is starting with $1,000. If her savings account earns interest, are we going to use a plus or are we going to use a minus? Plus. Hello, darling. All right, so here comes our new piece. We're going to put a fraction. On the top goes our rate. What are we going to put there? 0.04. Our rate, that's the wrong color. Rate as a decimal. I'm going to put our 0.04. Another color. So when we're looking at this N, there we go, red. What that means is we're going to look at this word here and figure out how many times it happens in a year. Annually feels like it's giving you a trick question because annually means once per year. So that means our n is 1. So then when we go to our exponent, we're going to put our n, so we're going to put our 1 again, times the time. What is our t? 18. It's this one right here. So we're just really adding one more piece. And we're going to type it into the calculator, which I haven't opened yet today. And oh, it is opening on the right page. Huzzah. Give my calculator a second to load. All right. So with these ones that are compounded, we're not going to do a ton of simplifying in the parentheses. We're just going to type it in the calculator uber duper carefully. So we're going to have our 1,000 times 1 plus, and then we have our fraction button, second column, third button down, this one right here. And we can put our 0.04 over 1 and raise it to the exponent of 1 times 18. So it winds up being so long that it can't even all show on the screen. So you need to be super duper careful when we're typing it in.
Students that are read testing this morning should head to their testing room at this time. Thank you.
Oh, these two were short today. And so we get this value when we type it in. So for putting $1,000 into a bank account and leaving it sit for 18 years, you more than double your money. Which is not too shabby for a regular savings account. That's not too shabby. So we get $2,025.81. I forgot. 582, because we're gonna round. We're gonna round right here to the nearest penny. So then we're going to calculate the same situation, but what has changed is we're no longer going to be compounding annually. We're going to try compounding monthly. So we're going to use a different piece here. So most of the pieces are the same. She's still going to start out with $1,000. She is still adding to earn interest. We have a fraction. It's still getting 4%. The only piece that's different is they're going to compound it monthly, which means we need to know how many months are in a year. There's 12 months in 1 year. That's all we're asking. So we're going to put a 12 as our n. That's all that means. So since there's 12 months in a year, our n equals 12. So we put a 12 in our denominator, and then we have to remember to put that 12 up in our exponent as well. So we're going to have 12 times that unit of time. There's our 18. And we're going to type that in the calculator. So we have our 1,000 times 1 plus our fraction of 0.04 over 12 raised to the exponent of 12 times 18. So there's, again, a lot of pieces in here. And it can't all show on the calculator at once. You can go back and forth through it if you need to. But the fact that they compounded interest every month without changing anything else about the situation gave her another $26. So $2,051.97. So it's a little awkward to get used to, but questions as it stands right now. Like, they don't get worse. They don't get worse. They're kind of weird, but they don't get worse. Okay, we're going to do a couple more situations like this. So we've got Jadion is opening a savings account with $10,000 that charges a fee of 1% per year. We're calculating his balance if that interest is calculated monthly or daily. Okay, so they're charging him a fee to have the account open, which they sometimes do. So read all the paperwork carefully when you have a bank account. So I'm going to write our form over here again. Where we have that the amount in our account is our principal, 1 plus or minus R over N to the NT. So we're going to start with filling in the pieces we have. What is our principal? What's our starting amount? I heard it. 10,000. Are we going to use a plus or a minus? Minus, because they're charging him a fee. And we're going to have our fraction. What's our rate? Yep. 1% as a decimal is our 0.01, or just 0.01. Woo, wrong pen. All right, if we are going to be compounding monthly, what is our N? 12. Because there's 12 months in a year. So it's going to be a 12 down here, which means we also need a 12 up here. Oh, they didn't give us a time to do. Let's do 5 years. Because they didn't tell us. I'm making it up right now because I wrote the problem. I just made that up because I didn't write it down on the slide. Okay, so we're going to calculate it at 5 years because otherwise we would be left with a variable and we couldn't finish it out. And I like to practice typing it in the calculator. That's called I was supposed to type it in, and I got caught up in picking names from other classes. All right, so we have 10,000. Yeah, making sure. Then we're going to do our 1 minus our fraction of 0.01 over 12. And we're calculating that to the power of 12 times 5. So we're typing it in the calculator. Super duper carefully. And over the course of 5 years, they charge him $500. Almost. So 9,512.10, because we would be rounding here. This 5 pushes this up, which pushes this up. So 10 cents. So after 5 years, if he puts $10,000 in the bank and forgets about it, because that would be a lovely life to have, be able to forget about 10 grand, man, that'd be nice. He would only have 9,512 left. Let's see how much different it is if they calculate that balance daily. So the only piece that changes is our compounding factor. The only piece that changes is our n if we change what it's compounding by. What is our new n going to be? 365. It's all about how many of these there are in our unit. So how many days in a year? There's 365. So everything else stays the same. Our 10,000 is still the same. We're still going to have 1 minus our 0.01. We're still going to calculate it at 5 years. The only thing that's different is now our n is 365 in both places. 365 times 5. That is trash. I'm going to rewrite that 3. Better. Kind of. And so we're going to type it in our calculator and see what the difference is if they calculate this interest daily. So we're going to take our 10,000 times 1 minus the fraction of 0.01, 1 not a 4, over 365. We're going to close our parentheses, raise it to 365 times 5. So it's the same equation as above, just with 365 instead of a 12. And we get very little change. 9,512. Only thing that changes is the cents. So it's going to be 29 cents instead of 10 cents. $9,512 and 29 cents, right? Yes. Haha. So as these n's get bigger and bigger, as they compound it more and more and more times, the amount that it changes shrinks. So it's changing by smaller and smaller and smaller and smaller amounts as we get bigger and bigger and bigger. Okay, so it's totally normal when you're doing these for if we're going from annually to monthly for there to be a decent change. Monthly to the daily, a very, very small change. And if you find anything smaller, it's going to be even less of a change. And we'll talk about more of that on Monday. We're going to do one more of these just to keep practicing putting things in the calculators and stuff. Writing these equations out. Okay? So this will be the last one for today, and then you guys will have time to work on the homework because there were 3 questions like this on the homework. So again, I'm going to put our equation up here. Our amount is our principal, 1 plus or minus the fraction with our rate over n to the nt. We will give you these formulas on the quiz, or test when we get to them. We give them to you. They get printed at the top of the page. You do not have to memorize them. In fact, I may go dig through my old posters and see if I can find my one with all these formulas on it to put up on the wall. All right, so let's fill in what we got. What do we have? 5,000. That's our starting amount, or our principal is the other word for that. So we're starting with a 5,000. Wrong color. Are we going to use the plus or the minus? The plus. We know that because it says it pays. It gives us. We are going to grow the balance. It's getting bigger. We're going to put our fraction. What's going to go on top? Yep, 0.039. What's going to go on the bottom for the first one? This is a new one. We can't use this word yet. But I say it's quarterly. Think about quarters. 4. There's 4 quarters in a year. That tends to be used more in things like business banking. They talk a lot more about like fiscal quarters. But that goes as our N. In both places we have an N. And then what's our T? 8. Another color. There we go. 8. So let's find Luna's bank account balance. She's going to go to her calculator, and we're going to have 5,000 times 1 plus the fraction of 1 plus 0.039 over 4 raised to the exponent of 4 times, I do not remember what number it is, 8. That is the benefit of having a physical calculator. You don't have to change your view to look at your paperwork again. So we get $6,820 and 45.8 cents. So watch how we round it. 2 decimal places for money. That is going to make that go up. So we're going to have 46 cents. So 68.20, 46. 68.20, 46. So our next piece, looking at our next one, we're compounding the same situation, but they've changed it to compounding daily instead of compounding quarterly. So what is our N on this one? Perfection, 365. 365 days in a year. So everything else stays the same. So we're still going to have our 5,000. We're going to have our 1 plus the fraction of 0.039. But this time it's over that 365 to the exponent of 365 times 8. So everything stays the same except for our N, our new piece today. And we're going to type it in the calculator, and this is the last one. I'm going to take a shortcut. There we go. All right, so get the whole thing typed into your calculator. And we get 10 additional dollars and 20 additional cents. 21 additional cents. No, 20 cents. So we get 68.30 and 66. No, I'm doubting. 66? Yep, 66 cents. So that's what those 3 questions on the homework yesterday were all about that we couldn't do yesterday because we didn't know how to do our compounding. But now we do. So you're going to need to make sure you have this equation in order to do those 3 questions on the homework. I didn't put it on the homework, so you need to make sure you have this written down somewhere. I will put it on our announcement page. I'll write it over here to the side just in case you didn't get it written down because you need to have it in order to do those homework questions. There we go. That's our equation. So I wrote it over there on the announcements page so you can have it. So homework 7-2, that's the one I gave you guys yesterday. You guys can work on that now. That was intense. Yes, dear. Yeah, absolutely. Let me write you a pass. You can also work on our 2-7 that was on Alex. That was the day that I was gone. It is an assignment. So if you have not done that yet, please go do so. I had more people in this class than in any other class do it, but it's still not tons of y'all. We're going to be doing a skills check next Thursday on the e-learning day on Canvas. So at home, you're going to do like an at-home quiz. Okay? That's the plan. There we go. And you guys have about 10 minutes until announcements start. Yes, sir. Say what? I still can't hear you.
The homework from yesterday.
The homework from yesterday, it's in the gold folder right behind the tree. Take it down. Please, I got it.